We've gone through the properties already of parallelograms and their conditions. We're now going to go through the properties of rectangles, rhombuses, and squares and their conditions. So, something interesting that you guys will find out if you guys haven't already is so much information about rectangles, rhombuses, and squares that can be interchangeably or that they share one from one shape to the other, right? One quadrilateral into the other. Something that we do know, or we can go ahead and state, is that we do have parallelograms in this case. These are special type of parallelograms, just basically like those special conditions of parallelograms. Now, let's go ahead and go on to our definition. So first definition that we are going into is a rectangle. And the way that we're going to go ahead and look at it here in geometry is a quadrilateral with 4 right angles. So this is what we know about a rectangle. 4 right angles, a quadrilateral with 4 right angles. And we can go ahead and see that the figure here that we have here shows rectangle A, B, C, and D. So that's the way that I'm going to go ahead and refer to it, rectangle A, B, C, D. We know that each vertices or each vertex here is going to have a measurement of 90 degrees. We know some information based on our previously, what we previously learned like in 5th grade, 3rd grade about rectangles, about their measurements and everything else. But we're going to go ahead and apply their official measurements here. Why is it that like the sides are, some sides are congruent? Why? Like how? Okay. So we're going to go ahead and make that statement today. The next shape that we have, or our next quadrilateral, is a rhombus. And it is a quadrilateral. It's different from a rectangle because we have 4 congruent sides. It does not necessarily have its angles as right measurements or right angles, but something that we do have as a rhombus is 4 equal sides, 4 congruent sides. So here in this case, we have rhombus JKLM, right? So notice all sides are going to be congruent to each other. And the last one is like what we say, a combination of them both. So a combination of a rectangle and a combination of a rhombus is what we call a square. Now, what is a square? A square is a quadrilateral with 4 congruent sides and 4 right angles. So when we see that Venn diagram that we saw in our assignment last time, and I'm going to go ahead and bring it back, we can see what are their similarities, what are their differences, what is it that they have in common, and what is it that they do not have in common, right? So in this case, a square is a combination of them both. All right, so this is what you guys saw. You guys noticed that we have a rhombus, we have a rectangle, and both together have in common a square. We can go ahead and classify a square to be a rhombus and a square to be a rectangle. And there's some cases where we can go ahead and classify a rhombus to be a rectangle, and some cases that a rectangle can be a rhombus. That's if they're basically a square, right? So if you're a square, you can go ahead and be either or. But something that they all have in common is that they're all going to be parallelograms. So their properties, like I said right now, are going to be applied to these 3 next quadrilaterals. So which brings us up to our next theorem about the properties of rectangles. So this one has 2 bullet points because it has 2 statements, and those 2 statements are very important. We're going to go ahead and read the first one. It says, if a quadrilateral is a rectangle, then it's a parallelogram, like I stated. And if a parallelogram is a rectangle, then its diagonals are congruent. I'm not going to prove this. I'm going to go ahead and apply it today and make a list of what is true about parallelograms so that we can go ahead and apply it to a rectangle. Because if we have a rectangle, then it's automatically a parallelogram. So go ahead and copy this down so you guys can have it in your notes. I'll give you about 20 seconds, 30 seconds. Let me go ahead and go over my list here. So we're going to go ahead and make a list of what's true about parallelograms. And I'm going to need your guys' help, okay? So I know you guys are there. I know you guys are present, so I'm going to ask you guys to tell me what are some properties of parallelograms that you guys remember? What is true? Meaning about their sides, their angles, diagonals.
They have two pairs of parallel sides.
They have two sides of parallel sides. So we have AD, BC. These two sides are parallel. So we can say AB, oops, is parallel to DC. And let's see, AD is parallel to BC. So because if we have a rectangle, we're going to also have a parallelogram. We can go ahead and also apply this information to a rectangle. So a rectangle also has opposite sides that are parallel to each other. Andale bien, opposite angles are equal. Yes, they're congruent. So angle A is going to be congruent to angle C, and angle D is going to be congruent to angle B. So their opposite angles are congruent. And are they congruent? Yes, they're all 90 degrees in this case, but opposite angles are still congruent to each other. So opposite angles are congruent. All right, what's one more? Actually, there's two more. Something about opposite something. Ms. Gomez, yes, diagonals do bisect each other. So diagonals bisect each other. So it means that a DB or BD, in this case, this segment right here, is going to bisect AC, and it's going to create two equal segments, right? So these two are congruent. But something that I want to point out, and this is going to be very important, the second bullet point says if a parallelogram is a rectangle, which we do have here, then their diagonals are congruent. So let's say if DB measures, let's say 10 centimeters. We know that we also have a parallelogram, meaning that they're going to be bisecting each other, right? So this segment right here created by E, let's go ahead and say this is me. E is my intersection. This one is also going to be 5 centimeters. This one's also going to be 5 centimeters. But because their diagonals are congruent, congruent means that they are the same measurement. DB, in this case, is going to be congruent to AC. And because they bisect each other, if this one measures 10 centimeters as well, this length AE will also be 5 centimeters. This one will also be 5 centimeters. Okay. Thank you for letting me know. I just saw your message. So in this case, diagonals do bisect each other. And something that we're going to go ahead and say, they create congruent segments. Congruent segments. All right. And the last one. One more. One last one. Let me go ahead and delete my little ticks because I know now that they're all going to be equal to each other. It's something very similar to their opposite. We said opposite angles. They also have opposite sides. We already said that they're parallel, but what also do we know? They are opposite sides. Are congruent. So we also know that the opposite sides are congruent. So meaning that AD, whatever it measures, it's going to be congruent to BC. And AB will also be congruent to DC in this case. So all of this information is going to be true about a rectangle. How? Because we have a parallelogram as a rectangle, right? So whenever we have a rectangle, it's going to be also classified as a parallelogram. And everything that is true about parallelograms is going to be true about rectangles. And in addition, diagonals are going to be congruent to each other. So this is what's a little more important about rectangles. So this is like a special condition or a special case in this case about a parallelogram. The diagonals happen to be congruent to each other. All right. I'll give you guys a couple minutes to copy the rest of this down so you guys can have it. So remember that the diagonals bisect each other, meaning that they cut each other in half. They're also congruent to one another. So therefore, all the segments that are created by those diagonals, the 4 segments, will also be congruent to each other. You guys ready for the first example? All right. Let me go ahead and clear. All right, so we're going to go ahead and go into example number 1. We have AD equals 7.5 centimeters. We have DC equals 10 centimeters. We have to find the measurement of DB. We are given the rectangle ABCD. Notice that all angles, it has 4 right angles inside of it. And we are given the diagonals as well. But let's go ahead and apply the information that's given first so that we can go ahead and then identify what do we need to solve for. So here we have AD. AD is right here. This side measures 7.5 centimeters. We're also given DC. Let me go ahead and bring out DC. It's right here. It's in blue. DC is right below here. This one measures 10 centimeters, and we're trying to find DB. DB is this diagonal. Now, something that I'm going to point out is that we're going to go ahead and apply some of the properties of the parallelogram to this rectangle so that we can go ahead and move forward and solve. So what can we say about my segment? Here I know that AD measures 7.5 centimeters. We stated that opposite sides are going to be parallel and congruent to each other. So I'm going to go ahead and apply it to BC. So if AD measures 7.5 centimeters, BC will also measure 7.5 centimeters. Now, what am I going to do here? I'm going to go ahead and extract a little piece from my rectangle so that I can go ahead and see the section here that I'm interested. I'm interested in this little piece, DB, right? So let me go ahead and extract it. So here is my length BC. Here is my length DC. Imagine that it's super straight. And then here's my length DB, right, in green. And notice that in this corner right here for angle C, we have a beautiful right angle. Now I know the measurement for this one, this length, 7.5 centimeters. I know the measurement for this length, 10 centimeters. How do I find the measurement of that missing length? Can you guys tell me? Can you guys remember? What can we use that we've learned before or that we've recalled before to find the missing length of a right triangle?
The Pythagorean theorem.
The Pythagorean theorem. So our little friend is going to come back. So C squared equals our sum of the square of our legs, A squared plus B squared. And I'm going to go ahead and substitute it so that I'm able to see it in segments. So C, I know it's going to be DB. DB squared. So whatever measurement this is. A, it's going to be whichever one you decide to assign. It can be this one, A. So this one is going to be my BC squared. And B is going to be, let's go ahead and make this one B. It doesn't matter, to be honest, as long as you know that these two are your legs, right? So DC. Now we know that we have C squared. We do have to isolate it. So we have to do that inverse operation, which is square root both sides. We're left with the length of DB is going to equal the square root of the length of BC squared plus DC squared. I'm going to go ahead and use parentheses because I don't want you to confuse C with C over here. This is just talking about a length, the segment, right? It's talking about the measurement of the segment, okay? So let's go ahead and use now our formula so that we can go ahead and substitute all those values here. And we have DB equals the square root. BC, we said it was BC 7.5 squared. DC is 10 squared. And we're going to go ahead and continue to solve. So let's go ahead and continue. 7.5 squared is, you guys have calculators? I know it's 56 point something. Yeah, 56.25 plus 10 squared is 100. Gives me the square root of 156.25, sorry. And I'm going to go ahead and continue and do the square root. So it's going to be radical, which is mean that we're going to have a decimal value, which is okay. We have now, I think it's about 12.5 centimeters in this case. So we know that the measurement of DB is 12.5. centimeters. All right. So a little hint, guys, when you guys are doing your homework, I do suggest for you to use your Desmos calculator, Desmos scientific calculator. You guys can go ahead and access it in desmos.com. Let me go ahead and clear my screen very quickly. I can bring it back. Just hold on. Give me a second. I can give you guys access to the scientific calculator. So go to desmos.com. If you go to Math Tools, Scientific Calculator, it automatically prompts the scientific calculator where you have your square roots, your parentheses, your squares, all that good stuff that you need. Okay? So let me bring back my information again. So that all this work, you can go ahead and type it out all together, and then you don't need to type it out one by one like you would on your calculator on your phone if you're using your phone's calculator. Trust me, it's much more accurate and less confusing to use. Any questions on this one? So we're dealing with right angles, which means that in order for us to find the diagonals, we're bringing back that Pythagorean theorem. If we were trying to find the hypotenuse, we do have to find the square root of both sides. And we are doing a squared plus b squared, the square root of all that. I know I did change the values to our letters, but that's because I was trying to personalize it or specify it to this particular example. All right, let me save an image. Are you guys ready for the next one? Yeah, okay. Let me go ahead and clear. All right, so let's go on to the next one, example number 2. Let's go ahead and see where we have AB is 17 centimeters, BC is 12.75. We have to find the measurement of DB once again, but let's go ahead and see what information is given. We're given AB. Let me see, did I do it in red last time? Yes, I did. Let's put AB, this one right here. AB is this length now. This one's 17 centimeters. BC is this length, BC. The height of a rectangle, this one is 12.75. we have to find the hypotenuse, or one of the diagonals actually. We haven't made it a hypotenuse yet. This hypotenuse. And we know that we can go ahead and apply that particular information from a parallelogram onto the rectangle. So we're trying to create the beautiful right triangle. So you can go ahead and, you know, whichever one you decide to choose, you can go ahead and choose this right triangle, this one. So therefore you can go ahead and say DC is also congruent to AB. And if you do, you've created your right triangle. This one's also 17 centimeters. Or you can go ahead and use this other information where AD is also 12.75 centimeters. I'm using this information so that you can go ahead and extract that triangle and visualize your sides, your segments, so that it can be something like this. Here's one of my lengths, one of my legs. Here's my other leg. And here's that diagonal, right? The hypotenuse to that right triangle that's created inside of a right triangle, or a rectangle, sorry. So here's B, here's C, and here's D. This one is 12.75. This one is 17 centimeters. And we're trying to find the length of DB. Do you guys remember DB? It's going to be equal to the square root BC squared plus DC squared. All right, I'll let you guys do this one on your own. Let's see what you guys get. I'll set it up for you guys. Okay. Alec is done. He was like, ready. DB equals, he said 21.25 centimeters. Agree, disagree? Come on, it's the Pythagorean theorem. You guys should know this. All right, let me go ahead and work this one out. So this one, it says BC is 12.75 squared. DC is 17. So this will give us whatever 12.75 squared is plus whatever 17 squared is. And I know it's 451.5625. Woo! It's a big number. And from here, we're going to go ahead and take the square root of that, and it's going to give us 21.25 centimeters long. So in this case, yes, I'm going to go ahead and continue and leave it how it is. All right, centimeters. All right, any questions on this one? No. So far, so good. Okay, so we're going to bring back again the Pythagorean theorem just a little bit to help us find that missing hypotenuse. And we're going to go ahead and use the legs, square them, each value, add them together, and take the square root. All right, let me go ahead and clear. Let's go on to our last example. Okay, I'm going to go ahead and give you guys some time to copy this one down. This is a modern artist sculpture, has rectangular faces. The face shown here is 9 feet long and 4 feet wide. Find each measure in simplest radical form. And it's going to ask you to use a hint of using the Pythagorean theorem. So I'm going to go ahead and let you guys think for a little bit. Just give you guys 10 seconds to think. You guys, what is the measurement to DC? You guys can use the chat box as well if you guys want to. So what's my measurement to DC? Are you guys there? Jessica, thank you. 9 feet. So 9 feet DC, if you guys remember, is right here. Let me go ahead and highlight it in a different color. Right here. And we know that opposite sides in a rectangle are congruent. So if this one's 9 feet, this one's also going to be 9 feet. Thank you guys for participating. All right, next one, AD. What's the measurement for AD? 4 feet. Yes, so we know that this side here is AD. Its opposite side is BC. If BC measures 4 feet, this one will also measure 4 feet. Now, once we're here, we can go ahead and see what's DB in this case. DB is the diagonal. So let me go ahead and highlight that diagonal. And again, we can go ahead and assume that our right angles, or our angles are right angles because we have a rectangle here. And we can go ahead and bring it out. So we have a right angle here, bring it out so that we can go ahead and find that measurement for DB. Here's one of our legs. And here is the height of that triangle. Go ahead and assume that it's a right triangle, even though it doesn't look like a right triangle. This one is 9 feet. This length is 4 feet. And we're trying to find the hypotenuse to this right triangle, which is also the diagonal to this rectangle. So D, C, and B. We're trying to find D, B in this case. So what is the measurement of that there? We know that DB is going to equal the square root of, let's see, BC in this case, squared plus DC squared. We have, let's see, square root, 4 squared, 9 squared. Let's see, square root of 16 plus 9. No, 16 plus 81. In this case, will give us a square root of 97. We can go ahead and approximate to our simplest form here. So what would be the square root of 97 in decimal value? It would be 9.84 feet in this case. Or if you guys want to approximate to the nearest tenth, 9.9, or no, 9.8, sorry. 9.8 feet. All right, so here comes a tricky question. So my tricky question is that we have to find the measurement of AE. Now, you guys must be wondering, like, AE, how do we find that? We haven't done that before. Well, in the definition or in the theorem of the property of rectangles, we said that if we had a parallelogram and it is a rectangle, then the diagonals are congruent to each other, right? So we know that now that DB, whatever it measures, it's going to be the same as AC, right? Yes. Now, because these two are going to be the same measurement, and we also know that because we have parallelograms, they're going to bisect each other. So if this measurement is equal to this measurement, and they're both congruent, this measurement is going to equal this measurement as well. So if this entire diagonal measures 9.84 feet, what is the measurement of this little segment here? In that case, yes, that is correct. Let me go ahead and give my other color. It would be 4.92, yeah. 4.92. You guys must be wondering why or how. Where do we get 4.92? Well, they bisect each other, meaning that they cut each other in half because they're the same segment. They cut each other in half. Therefore, whatever dB measures, we can go ahead and divide it by 2. So 9.84 divided by 2 gives us 9.92 feet in this case. Any questions for this this lesson? I don't know if that was a question or not. All right. So with this said, this concludes our